tomatoes are well loved by many, yet for organic farmers, there's little information available on organic nitrogen management for production in California. Some basic information to have would be, how much nitrogen do pole-grown fresh market tomatoes need? And when in the season do they need it? And then there's the aspects of the organic soil amendments, such as how much of the nitrogen becomes plant available, and when does it become plant available? With collaborators at UC Davis, we undertook a project to answer those questions. But before I get into that, why is nitrogen so important? Let's go talk with my collaborator, Dr. Daniel Geisler, to find out.
Nitrogen is an essential nutrient for plants, and it's needed for proteins, DNA and chlorophyll, which in turn is used to capture sunlight and convert the energy into biomass. Plants need it in relatively large amounts, and it's important that they have access to nitrogen at the right time in sufficient quantities to reach their full potential. But if too much nitrogen is available, then there's the risk of leaching one form of nitrogen, which is nitrate, to the groundwater. Timing is especially challenging in organic systems because most of the nitrogen on organic farms is applied with organic sources like manure or cover crop or compost. And organic nitrogen is not directly available to the crops. It needs to be converted to mineral forms of nitrogen by soil microorganisms.
To do this research, the Geisler Lab and I worked with growers in our area, the northern Sacramento Valley, to test the materials that they use to grow tomatoes. Typically, one will use a compost, manure-based or yard trimmings-based, along with a couple of fertilizers, perhaps guano or pelleted chicken manure. Over 2 years, we tested several combinations of these materials, both on growers' farms and at our UC Davis research site. Over the season, we collected plant and soil samples to analyze for nitrogen content, and then we harvested, sorted, and weighed all of the fruit. Now that the work is done, let's go back and talk with Daniel to find out what we learned about how much nitrogen Brandywine tomatoes need.
In our trials, we found that Brandywine tomatoes take up between 150 and 250 pounds of nitrogen per acre in a season, or on average, roughly 200 pounds per acre. However, the amount taken up by the plants really depends on the yield level. And what we found is that when we added up all the nitrogen in the vines, in the harvested tomatoes and in the culled tomatoes, that on average the plants took up about 6.5 pounds of nitrogen per ton of yield. It's important to include cull fruits when we do a nitrogen budget. What we found is that in our trial, about 50% of the harvested fruits had to be culled with Brandywine tomatoes. And of all the nitrogen in the plant, about 18% of the nitrogen was in the marketable fruit, 80% in the cull, and the rest, 64% or roughly 2/3, was in the vines and unripe fruits at the end of the season. When calculating a nitrogen budget, it's important to include the cull fruits and the marketable yield, and then calculate how much nitrogen the plants may take up during the season.
Now that we know how much nitrogen the tomato crop needs, when in the season does it need it? Let's go talk with Patricia, one of the scientists in the Geisler Lab, to find out.
Tomato nitrogen uptake follows 3 distinct phases. First, from transplanting through early bloom, they take up very little nitrogen, less than 25 pounds per acre. From full bloom through early harvest is the period of rapid uptake, where tomatoes take up about 70% of their total requirement. During this time, rates can be as high as 3 to 5 pounds of nitrogen per acre every day. In the third phase, nitrogen uptake from the soil slows down. Now, harvest occurs over many weeks, but the plant is actually able to remobilize nitrogen from its lower leaves to develop those fruit. And that's why you see the lower leaves starting to look pale later on in the season. But this means that if you apply nitrogen to the soil from the mid-harvest through the late harvest, the plant's probably not going to take it up.
Organic soil amendments, compost, fertilizers, and liquid products are at the core of a nitrogen plan. However, most of these require microbial processes to break down the material before releasing the nitrogen in a plant-available form, making it hard to know when the nitrogen is plant available. To study this, we took organic amendments, added them to organic field soil from a grower's farm, and incubated them under optimum soil temperature and moisture conditions, all the while monitoring nitrogen mineralization. The materials we included were several composts, a few fertilizers, and liquid products. From these incubations, distinct trends emerged. Patricia's going to walk us through what we found in these incubations.
So let's start with the compost. Yard trimmings compost had very little nitrogen, less than 1%. And through the whole 12-week incubation, very little of it became available. So this is an amendment that's good for long-term fertility, but don't expect it to contribute much to your current crop demand. Now, poultry manure compost, on the other hand, had about 3 to 4% nitrogen, and of that, around 20% of it was immediately available at application. After that, it released nitrogen slowly, and after 12 weeks, about 30% of its nitrogen was available for uptake. The granular fertilizers also had about 15 to 20% of their nitrogen immediately available, but they released the rest of it more quickly within the first few weeks. And after the whole incubation, 30 to 60% of that N had become available. For the quick release amendments, the liquids and the guano, the release was even quicker, and about 65 to 100% of their nitrogen was potentially available. For the blood and feather meal, which are also quick release, there was almost no nitrogen initially available, but once they were mixed with soil, the release was very quick. Now, these tests, of course, were done in a lab, and so the conditions in your field will be different, and the actual timing depends on the soil temperature and on the moisture. So dry soils and cold soils will mineralize less quickly. However, the mineralization potential and the relationships between the materials should be similar.
Commonly, fertilizers and composts are added before transplant when the field is easily accessible. With moisture and somewhat warm soil conditions, the nitrogen will start to mineralize, releasing plant-available nitrate. As such, early in the season, there can be high amounts of nitrate in the soil. When we look at plant demand, rapid uptake does not begin until full bloom. Consequently, there is this interval of time at which there is high amounts of nitrate in the soil, but low crop demand. This is okay so long as there's careful irrigation management. The most plant-available form of nitrogen is nitrate, which moves where the water moves. We want to keep that nitrate in the root zone for the plants ready for the period of rapid uptake and not be removed to depths beyond the root or to underground or runoff water sources. Through this research, we've learned a lot, and we hope you have too. We learned that nitrogen demand in pole-grown heirloom tomatoes ranges from 150 to 250 pounds of nitrogen per acre, and there's about 6.5 pounds of nitrogen in a ton of fruit. 70% of nitrogen uptake occurs between full bloom and early harvest, as if the plants were hungry teenagers. And even though harvest continues over several weeks, late nitrogen additions will likely be unused. Organic soil amendments have somewhat predictable nitrogen release rates based on the type of material. Lastly, carefully manage irrigation when the plants are young and the crop nitrogen demand is low, but the pre-plant amendments are breaking down and releasing plant-available nitrate. If you have any questions, don't hesitate to contact us. Thanks.